Hi everyone, we're going to talk more about Avl insertion rules and go through a typical Avl insertion problem. Okay, so there are three main parts to doing an Avl insertion. The first step is to insert the node normally using BST insertion rules, which you should hopefully be familiar with by now. The second step is to check for a potential height imbalance. So the way that we can do this is by following the path that we took to insert our node in step 1, and checking the height of its left and right subtrees for each node. So like each node in the path. If the heights between the left and right subtrees for any node are off by more than 1, then we can consider this node to be imbalanced, which makes the tree imbalanced. And for step 3, if we find an imbalanced node in step 2, then we can apply rotation strategies from lecture to restore balance. So this is taken from one of the slides in lecture. So it turns out there's only two kinds of cases that can cause imbalance, which are the line and kink case. So as we're talking about these cases, I'll be referring to the node where the imbalance occurs as the parent node. Alright, so let's first talk about the line case. So there's two ways that we can end up in the line case. So the first way is if the element that we inserted is located in the left subtree of the parent's left child. So that's the picture on the very left. And the second way is if the element that we inserted is located in the right subtree of the parent's right child. So each of these cases can be solved by doing a single rotation. So I'll walk through a potential right rotation. So for this first example, we'll have to do a right rotation on this 3 in order to restore balance. So, the way that I like to think about right rotations is that I'm going to, bring this 2 up to where this 3 is and make 3 the right child of 2. So I'm going to rotate right, so I'm going to bring the 2 up, and then that will also drag its 1 up, and then we'll make 3 the right child of 2. So similarly, if we're going to do a left rotation, I'll bring the 2 up to where the 1 is, which drags the 3 up, and then I'll make 1 the left child. So both of these will end up, will have the same result. Alright, so there's also the kink case, which we can solve by using 2 rotations. So there's 2 ways that we can end up in the kink case. So the first way is if the element that we inserted is located in the right subtree of the parent's left child, and this other way is if the element that we inserted is located in the left subtree of the parent's right child. So in both of these cases, the element that we insert is 2. Alrighty, so kink resolution can be a little bit trickier because it requires 2 rotations. So for this right kink resolution, first we have to perform a left rotation on this 1. So when we're doing a left rotation, that means that we want to drag the 2 up to where the 1 is, and then we'll make 1 the left child of 2. So our tree ends up looking like this. So hopefully this looks really similar to the line case on the left because they are the same tree. So our second thing to do would be to rotate right on this 3. And then our result would just be this 1, 2, 3 tree over here. Left kink resolution is also kind of like the same thing, but kind of backwards. So the first thing that we need to do for left kink resolution is to rotate right on this 3. So we're going to drag the 2 up to where the 3 is. So our tree is going to look like 1, 2, and then 3. So 3 becomes the right child of 2. And then after we get this tree, then we're going to do a left rotation, which is going to be like the same as this image over here. Alrighty, so I know that was kind of a lot, but these problems become a little bit easier with practice, and we'll do a walkthrough, so hopefully seeing some examples and some practice will help solidify these. And I definitely recommend doing more of these problems if you're once you start to get the basics. Okay, so let's build up an Avl tree from scratch. So maybe the first thing I want to do is insert a 6. So step 1 is to insert it like you would in a BST. It's the first node, so we can just insert it, and we know that this is definitely balanced because both of its subtrees are 0, so we're done. The next thing that we might want to insert is 43. So 43 should be inserted to the left of 6, and now we need to check for balance. So it turns out that this is also balanced because for 43, our left subtree and our right subtrees are 0, and for 6, it's 0 and 1, and that these are off by only 1, so it's okay. Okay, so the next thing we might want to insert is 7. So 7 is going to be placed in the left of 43. Alrighty, so now we need to check if it's balanced or not, so we'll start at the 7 and calculate the height of its subtree, so this will be 0, 0. For 43, it'll be 1, 0, this is okay, so these both are okay. And then for 6, it's 0, 2. And this is not okay, because they're off by more than 1. So this is a kink case because 7 was inserted to the left of 43, which is 6's right child. So this means that this is a kink case, so we'll have to first do a right rotation on 43, and then we'll do a left rotation on 6 later. So remember, for a right rotation, we're going to bring up the 7 to where 43 is, and 43 is going to become the right child of 7. So after doing our right rotation, our tree will look like this, which means that now we need to do the left rotation on 6. So if we do the left rotation on 6, we'll bring 7 up to where 6 is, and then 6 becomes the left child of 7. So now our tree is going to look like this. So we just finished doing both of our rotations, so we're done. So we'll never have to do like more than 2 rotations in order to restore balance. Okay, so the next element that we'll insert is 42. So 42 is going to be inserted to the left of 43. And now that we've inserted it, we should check for any potential imbalance. So 42, our subtrees are 0 and 0, so this is good. For 43, it's 1, 0. This is also okay because they're just off by 1. And then for 7, it's 1, 2. And this is also good. And now we're done because we've checked the entire path and they're all balanced. Okay, so the next thing that we'll insert is 59. 59 is going to be inserted to the right of 43. And now we'll calculate the subtree heights. So 59 is 0, 0. 43 is going to be 1, 1. And then 7 is going to be 1, 2. So these are all okay because they're never off by more than 1, which means that we're done. Okay, so the next thing that we're going to insert is the 63. So 63 is going to be placed at the right of 59. So now we'll check for any imbalance. So 63 is going to be 0, 0. 59, so this is okay. 59 is going to be 0, 1. This is also okay. 43 is going to be 1, 2. This is okay. And then 7 is going to be 1, 3. And this is not okay. So we found our node where the imbalance starts to be 7. So now we need to figure out what kind of rotation we need to do to fix this. So this is going to be a line case because 63 was inserted to the right of 43, which is 7's right child. So that means that we can fix this by doing a single left rotation on 7. So when we're doing a left rotation, that means that we want to bring 43 up to where 7 is, and we'll move 7 to be the left child of 43. So after doing our left rotation, we'll have something like this. I'm not going to draw all the nodes. 59. And then there's going to be some other nodes here. So yeah, it'll also have like some left node. So one thing that you might be wondering is what happens to this 42, because 43 already has a left child. So one observation that we can make is that because 42 is to the right of 7 and to the left of 43, that we could actually just like stick it as the right child of 7. Because since it's like in between these two values, we can also say, like, if we put it into this BST, you'd notice that it says like less than 43 and greater than 7, which is pretty much like the same thing that we'd said earlier. Okay, cool. So the rotation ends up looking like this. So we dragged 43 up and then we stuck 42 to be the right child of 7. And now that we've done this rotation, so now we're done with this node. Okay, cool. So the next thing that we might want to insert is 11. So 11 is going to be inserted at the left child of 42. And now we'll check for AVL imbalance. So this is going to be 0, 0. 42, it'll be 1, 0. Right, so both of these are okay. And then at 7, it'll be 1, 2. This is okay. And then 43 is going to be 3, 2, which is also okay. So these are all balanced, so we're done. So we'll move on to the next thing. So next thing that we'll insert is 21. So 21 is going to be inserted over here at right child of 11. So now we get to check for AVL imbalance again. So for 21 it'll be 0, 0. This is okay. 11 will be 0, 1. This is also okay. And then for 42 we'll have 2, 0. And this is not okay, which means that we'll have to do some rotations. So 42 is going to be where we're imbalanced. So now we have to figure out which case this is. So this is going to be a kink case because 21 is the right subtree of 11, which is 42's left child. So to fix this, we'll first do a left rotation on 11, and then we'll do a right rotation on 42. So for our left rotation, we'll bring up 21 to where 11 is, and we'll make 11 the left child of 21. So this is what happened. So this is like the result from doing the left rotation. So now we'll do our right rotation to finish doing our kink resolution. So for right rotation, we'll bring 21 up to where 42 is and make 42 the right child of 21. So this will be our finished tree. Okay, so we'll insert 56 now. So 56 is going to be inserted to the left of 59. Oh yeah, oops. Well, it turns out that this is balanced. So if we were to check all the heights over here, just for good practice, because I accidentally went to the slide a little bit early. So this is 0, 0, this is 1, 1, and then this is going to be 3, 2. So these are all okay because they're never off by more than 1. Okay, so the next thing that we'll insert is 54. So 54 is going to be inserted into the left child of, to the left of 56. So we can just mark the heights. So 54 subtrees are 0, 0. So this is okay. Heights of 56 is left and right subtrees are 1, 0, which is okay. For 59, it's 2, 1. This is okay. And then for 43, it's going to be 3, 3. And this is also okay. So that means that we're done. Okay. Next element we'll insert is 27. So 27 is going to be inserted at the left of 42. So we'll check for our AVL balance. So this is 0, 0. This is okay. This is 1, 0. This is also okay. This is 1, 2. This is also okay. And then this is 1, 3. This is not okay. So 7 is where imbalance is. So now we have to figure out what rotations we'll need to use. so notice that 27 is in the right subtree of 21, which is 7's right child. So this means that we're going to be in the straight case, which means that we just need to do one left rotation on 7 in order to restore balance. So when we're doing our left rotation, that means that we move 27 up to where the 7 is and make 7 the left child of 21. And since 21 has a left child already, we're going to move this to be the right child of 7 because this 11 is between 7 and 21. So that's like also an acceptable place for this 11 to be. So that's what's happened in this picture. So we moved 21 up, and then we dragged 11 over here to 7's right child. These cases are definitely a little bit tricky sometimes, so it's good to kind of go through a couple different examples. But anyways, so we finished doing this rotation, so we're now done. Alrighty. So the next thing that we'll insert is 20. So 20 is going to be inserted into the right, to the right of 11. Oh yeah, I forgot to write the different heights again, but for 20 it's going to be 0, 0. For 11 it'll be 0, 1. For 7 it'll be 1, 2. For 21 it'll be 3, 2. And for 43 it'll be 4, 3. So all of these are always going to be, these are all going to be with, all the heights are within 1 of each other, so these are all going to be balanced. Okay, next thing that we'll insert now is 36. So 36 is going to be inserted to the right of 27. So now we'll check for AVL balance again. So the difference. So these are 0, 0. So this is okay. For 27 will be 0, 1. This is okay. And then for 42 it'll be 2, 0. And this is not okay because the heights are off by more than 1. So 42 is where our imbalance is. So now we have to figure out which case that we're going to use to fix our tree. So this is going to be a kink case. So this looks like one of the examples that we showed earlier. So the way that we're going to fix it is by doing a left rotation on 27 and then a right rotation on 42. So for a left rotation, we'll drag 36 up to where 27 is and make 27 the left child of 36. So after doing our left rotation, we get this as our tree. So now we have to do our right rotation. So we'll do a right rotation on 42. So we drag 36 up to where this 42 is, and the 42 will become the right child of 36. So now this will be our tree. And now we're done. Okay, and I think that this is all of the, this should be like all of the rotations, and it should be all the notes that we're inserting, so we're done with this problem. Yeah, so definitely recommend trying more of these because practice will help make you feel a little bit more comfortable. Yeah, so good luck.